So here we are back to practicing finding the area for a surface that's being rotated around the x-axis. So before I even look at the function, I'm thinking, all right, surface area means you integrate 2 pi, and then there's the function, and then the square root of 1 plus the derivative squared, and then that would be with respect to x. And then I read the next line and it says, oh, you don't have a function of x, you have a function of y. So that means that we need to adjust just a little bit. And that is this right here is basically saying y. So right there, we just put y. And then instead of y prime, this is going to be x prime. And instead of dx, this is going to be dy. So that's the adjustment we need to make because this is a function of y instead of x. And then the limits are given 0 to 2 once we change it to the y. Okay, so instead of y prime, we need x prime. So take the derivative. So dx dy or x prime will equal. So take the 3/2, bring it in front and multiply. So there's going to be a 1/3 times 3/2. For now, the inside part stays y squared plus 2. And then when you subtract 1 from the exponent, 3/2 minus 1 will be 1/2. And don't forget the chain rule. The derivative of the inside will be a 2y. And then we could simplify this because we have things like the 3's are going to cancel, the 2's are going to cancel, and that's it for the canceling. So we've got that x prime is equal to a y squared plus 2, and then the 1/2 means that that is in a square root, and then outside the square root, there is the y. And I need to square the derivative, so I'm just going to do that part right now. So square both sides. So we've got that x prime squared. Well, on the right side, the square and square root will cancel. So there's going to be y squared plus 2 without the square root. And then it's also going to be times y squared. And I might as well go ahead and do this part right here where I add 1 to both sides. So 1 plus the x prime squared. And also start doing the algebra. If you distribute the y squared, there's going to be y to the 4th plus 2y squared. Okay, I think I'm ready to set up the integral. So the integral is going to be integrate from 0 to 2. So there's 2 pi, and then instead of f of x, you just put the letter y. And then there's going to be the square root. And then I did the algebra, so this is what goes inside the square root. Although I'm going to put it in order, y to the 4th plus 2y squared plus 1 dy. And if you tried u substitution on this one, it would not work. So we actually need to do algebra. And the algebra that we're going to do is factor this. So this actually can be factored into y squared plus 1 was squared. Because if you multiply this out, it would give you y to the 4th at the beginning. It would give you 1 squared or 1 at the end. And then when you multiply the two middle terms and double that, that's going to be the 2y squared. Which is really good news because that thing is then inside the square root. So the squared is going to get canceled. So we're left with integrate from 0 to 2, 2 pi, and then y. And once the square and the square root cancel, then there's just parentheses, y squared plus 1. And then one more step of algebra. And that would be just distribute the 2y. So then there would be y cubed plus y. So after all of that algebra, it pays off because it leaves us with very straightforward antiderivatives, which will be y to the fourth over 4 plus y squared over 2, and then evaluate that from 0 to 2. So there's 2 pi, and then 2 is to the fourth over 4 plus 2 squared over 2. And then when you substitute the 0, it's just going to be 0. So we just need to simplify this answer. So what's 2 to the fourth? 2, 4, 8, 16. So this one is 16 divided by 4. And 16 divided by 4 is going to be a 4. And then for the second fraction, that will be 4 divided by 2. And so all we're left with in the brackets is a 6. And 6 times 2 pi is 12 pi.